Welcome to this class. Today I am continuing the chapter Force and Motion of the subject Science and Technology of class 9. And this chapter is divided into 10 parts and we are presenting each of the part one after another, and this is part number 7. In part 1, I described and discussed a lot about the terms related to motion of the body. They were displacement, distance, scalar, vector, speed, velocity, average velocity, uniform velocity, non-uniform velocity, acceleration and retardation. All these terms were defined and discussed with example and graphical representation also in part 1. And then in part 2, I established 4 different equations. The equations were: number 1, B equal to U plus AT, number 2, S equal to U plus V by 2 into T, number 3, B square equal to U square plus 2 AS, and number 4, S equal to UT plus half AT square. I derived these 4 equations in part 2, and then in part 3 and 4 we used this equation to solve the numerical problems. And at that time I described how to solve the numerical problem. According to the given of the numerical problem, we have to select particular equation to solve particular numerical problem. They were done in part 3 and 4. And in part 5 and 6, we did graphical representation of the motion of the body. I mean to say, a body may be moving with uniform velocity, it may be moving with non-uniform velocity, or it may be moving with acceleration or retardation, or maybe uniform acceleration, non-uniform acceleration, etc., etc. Whatever it is, the motion of a body may be anything. Sometimes it comes to rest also. But the motion of the body in a straight line can be represented graphically, and that was taught in part 5 and part 6. I told you at that time, 3 major types of graphical representation. Number 1, displacement time graph. It was done in part 5 in detail. We draw different graph in that class. And then second type of graph, velocity time graph, was taught in part 6, and acceleration time graph is not done because it is not given in our book. That's why we can represent now the motion of a body by displacement time graph and velocity time graph. Now this is part 7. Now graphical representation is finished. Now we are starting some other part. What is that? Inertia. Today I am going to start inertia. Exactly what is inertia? On which factor it depends, and what are the types of inertia? What are the daily life experiences of inertia, etc. I am going to present now. But today I want to start with the video clip. I am presenting many short video clip to understand inertia in detail. Okay, look at the screen. A man is jumping on the net. This net is tied with the trees, and net is full of dry leaves. And when a person jumps over it, then what is seen? The net goes downward, but the leaves are left behind. It means leaf tends to continue its state of rest. This tendency of continuing the state of rest of the leaf is inertia. And leaves have inertia, and they tend to continue their state of rest. Now this is called inertia, but later I am going to define this also, but this tendency is shown in this video. The tendency of continuing the state of rest by the leaf is called inertia of rest. Okay, let's go to another video. This is a glass partially filled with water. An egg is taken, but above the glass there is a plate and a cylindrical object is placed over it, and at last at the top we have an egg. And if we pull that plate very fast, I mean to say, if we jock that plate to pull out, then what is seen? This egg falls down into the glass, because egg was at rest and it has tendency to continue the state of rest. That's why even after pulling off that plate, the egg continued its state of rest, and this, because of this inertia, it fell down into the glass. Now look at this another example. I am talking about the example of inertia. Okay, next look at this. This is a patient probably, and a girl, patient is a girl, and she is in a stretcher, and hurriedly driver moved the car, and this is their foolishness. This is because of this hurriedly moved, the body of the patient was at rest. It tends to continue its state of rest, and this is called inertia of rest. Because of inertia of rest, this patient fell down from this small truck. Okay, this is another example of inertia of rest video clip. Okay, next look at this. A dog is barking, and it is tied with a rope, and rope is tied with sledge, and when he moves away, when dog moves away, then sledge goes with him. But this children who was at rest, its body tends to continue the state of rest, and this is called inertia. Because of this inertia, the children is left behind, and the children fell down because of tendency of continuing its state of rest. All these are the example of inertia. The tendency to continue the state of rest is shown in these 4 different video clips. Now I want to show you some other. In that also I want to show the tendency of the object or the body to continue its state of motion. Look at this video. This is a man who wants to come out from a moving train. Look at this. This is probably a foolish person. He is coming out, opening the door of the train, and when he stepped on the platform, he fell down, because his body was moving with the train and it had tendency of the motion. I mean to say, it had inertia, and this inertia is called inertia of motion also. Later I will talk about the types of inertia. And because of this tendency of continuing the state of motion, when his feet touches the ground, the feet came to rest, but the upper part of the body continued the motion, and that's why he fell down badly. Okay, this is the tendency to continue the state of motion by a body. Okay, look at this another. This is an empty chair. Another chair is also shown there, and 3 books are placed over it. Books are heavy. When that chair is pushed towards a small chair having a little less height, when it is pushed faster, then what is seen? The books were in motion and it tends to continue its state of motion. That's why the books shifted its position forward. This is the example of tendency of continuation of the state of motion of the body. Okay, now next look at this. A rider is riding horse. Both of them were in motion, but all of a sudden when horse stops, then because of the tendency of the continuation of the motion, the rider, the girl, fell down, because her body has the tendency to continue the state of motion. That's why she fell down. This is inertia. And look at this. This is very interesting. A man is riding motorbike at very high speed, and he gained inertia, lot of inertia of the motion, and because of that huge inertia, he crossed a lake also. He crossed a lake also because of the huge inertia. Even after the less support of water, he crossed that. This is the example of inertia of motion. Now Now I want to tell you what exactly is inertia. Inertia means what? Now this is the time to define inertia. Look at this. We are going to define inertia. What is inertia? We can say this way: the inability of a material body, that means mass, to change its state of rest or uniform motion in a straight line is known as its inertia. Inability, what it means? If a body is at rest, it cannot change its state by itself. If a body is in motion, it cannot change its state by itself. They have inability to change their state by themselves. This tendency or this inability contained in a body at rest or body in the motion is called inertia contained in that body. Okay, it can be defined this way also. Inertia is the property of the body due to which it resists the change in its state of rest or uniform motion in a straight line. Inertia is that property in the body if at rest it resists the motion. I mean to say, it doesn't want to come to motion. And if a body is in motion, it doesn't want to come to rest. This way, the inertia is the property which resists the change of state of the body. Okay, this way we can define inertia. We can define these different ways. Okay, now I want to mention one law of inertia. All the object, all the bodies or matter which appears around us, or all the matter which is present in this universe, they have inertia, and all of them follow the law of inertia. This is also called natural law of inertia. I want to present this natural law of inertia. Exactly what is it? Look at this. Matter will remain at rest or continue in uniform motion in the same straight line unless acted upon by some external force. Now force came. What it means? If a body is at rest, it tends to continue its state of rest until and unless an external force is applied on it to change its state. If a body is in motion, then it continues its state of motion until and unless an external force is applied on it to stop it. And that's why this law of inertia also gives the definition of force. This means the force is an agent that can change the state of rest or motion of the body. This is law of inertia. Indirectly, it gives the definition of force also. Okay, now we talked a lot about the inertia. Now it's time to talk about the factor. What factor affects the inertia? Just for example, two bodies are at rest. Can we expect that one of them have more inertia and another has less inertia? And if two bodies are moving, then can we expect that one has more inertia of motion, another has less inertia? Okay, this I want to prove with small experiment. Look at this experiment. I have taken two identical plastic bottles. One of them is empty. Look at this, nothing inside it. And another is partially filled with water. Now certainly mass of this is greater than mass of this. Quantity of matter contained in a body is called mass of that body. Quantity of matter contained in this empty bottle is less, but quantity of matter contained in this bottle filled with a little amount of water is more. Mass of this is more, but mass of this is less. Okay, now what amount of force is needed to overcome the inertia of rest of this empty bottle? Now what I am talking about, I want to move it just like this. I want to move it like this. But what amount of force is needed to move it? That force represents the inertia present in this empty bottle. If it has less inertia, to overcome the less inertia, I have to apply less amount of force. And if it has more inertia, then I have to apply more force to overcome that more inertia. Which contains more inertia, which contains less inertia? Does it depend upon mass? I am going to show this. Look at this. This is spring balance. and I am using this spring balance to move first empty bottle. Now let's say I am moving towards this direction, and what amount of force is needed to move it is being measured here. What amount of force is needed is being measured here is very less. We can see this spring balance. Here the force is a little more than 0, very less, probably 0.02 to 0.04 Newton force is needed to move it from rest to motion. I am applying force on it, rest to motion. I want to overcome the inertia, and very less amount of force is applied. It means the inertia of rest present in this empty bottle is less. Now I want to use the same with this water filled bottle. Look at this. Here again force is applied. Now I am applying force to move it. Now you can see that the force required to move it is about 0.5 Newton. This is about 0.5 Newton, a lot in comparison with the previous 0.5 Newton. What it means? 0.5 Newton force is needed to overcome the inertia present in this water filled bottle, but very less, negligible amount of force is applied on this empty bottle to overcome that inertia of rest. It proves that inertia depends upon mass. Whenever we have at certain place, whenever we have certain body and we want to move it, then force is applied to move that body, means force is applied to overcome the inertia present on that body. And if its mass is more, then we have to apply more force, more inertia of rest is there, and that's why to overcome more inertia of rest we have to apply more force. But if mass is less, we have to apply less amount of force. Just for example, we can take example. In the construction of road, I think you have seen big roller, and this roller has very huge metallic wheel. And can we move this roller by pushing from any side? No. Its mass is huge, and we are applying force to overcome that mass. I mean to say, mass is huge, that's why inertia of rest is very huge, and against that huge inertia of rest, we cannot apply huge amount of force to overcome that inertia of rest. But if it is a small stone, we can push it very easily, because stone has less mass, less inertia of rest, and this can be moved easily, because against the less inertia of rest we can apply less amount of force easily and we can move it. In the same way, we can take example of moving body also. Just for example, if your friend is in bicycle and you want to stop him by holding the carrier of the bicycle, probably few steps you will be pulled by the bicycle, but you can stop that moving friend by holding the bicycle at the back, I mean to say at the carrier. But can you expect that a moving car can be stopped by holding it from back? No, because it has huge amount of inertia of motion. It has huge amount of inertia. To overcome that inertia, we cannot apply that much huge force, and that's why we cannot stop a moving car. That's why what is our conclusion? Our conclusion is very simple. Inertia depends upon mass. If a body has more inertia, it means its mass is more. If mass of a body is less, it contains less inertia, whether the body is at rest or in motion. Okay, then let's go to type of inertia. I want to present the type of inertia. Inertia is of two types. One is called inertia of rest. Another is called inertia of motion. Now, what exactly they are, I want to define inertia of rest and inertia of motion. What is inertia of rest? Inertia of rest is the tendency of a body at rest to continue its state of rest. If a body is at rest, it has tendency to continue its state of rest, and this is called inertia of rest. Now, I want to go through the previous video clips. Look at these video clips. These these leaves, the dry leaves were at rest and they had tendency to continue their state of rest. This is inertia of rest. Even after the support is moved away, support is net is moved away because a man is jumping over it. Even after this, they continued their state of rest, that's why separate from net, and later falls down due to gravity. Okay, in the same way, look at this. Here also, the egg had what? Tendency to continue its rest state, that is inertia of rest. Because of that reason, when a support is pulled, then because of the inertia, it continued its state of rest and fell down due to gravity. Now look at this also, the example of inertia of rest. The body of this patient had inertia of rest and it tends to continue the state of rest. That's why when the truck, a small truck, gone away very fast, then her body fell down on the road. Okay, here also these children, the body of the children had certain mass and it has tendency to continue its state of rest. This is inertia of rest, and to continue the inertia of rest, this sledge is pulled away but the children fell down. Okay, now why don't we do again some experiment to be clear about this inertia. I want to do something. Look at this experiment of inertia of rest. Look at this very simple experiment I am going to do here. Okay, look at this. A cup is taken. This is simple cup which we have in our houses, and a paper is placed over it, and just above the paper, over the paper, a coin is placed here. If I pull this paper very quickly, then coin falls down. Very simple experiment. Anyone can do this very easily. If we pull this paper very fast, then coin falls down. Why coin is not coming with this paper? The question is, why the coin is not coming with this paper? The reason is very simple. Coin was at rest. It tends to continue its state of rest, and when force is applied on the paper, and if at a jerk we pull the paper, then the coin which was at rest continuously, it tends to continue its state of rest, that's why fell down due to gravity. But another interesting matter probably is not discussed usually in class. If we pull it slowly, then look at this, coin doesn't fall into the cup. What is the reason? Reason is very simple. At this time coin is sharing the force applied on the paper, and if coin shares the force applied on the paper, then coin can be pulled with the paper. But if we take a jerk, then coin cannot share the force applied on the paper, and because of inertia of rest, it falls down into the cup. This is the example of inertia of rest of our daily life experience. Okay, next experiment also I want to do. Look at this. Okay, this is a pile of book. Many books are here. But if I draw, I mean to say, if I pull one of the book from the pile very quickly like this, now it came in my hand but pile doesn't fall. Again, look at this again. If I pull one of the book from this pile this way, pile doesn't fall. What it mean? The book in the pile, they had inertia of rest and they have tendency to continue their state of rest. That's why when I pulled a book from the middle part or from the bottom, then force is applied only on that book. Remaining book had inertia of rest and they continued the inertia of rest. So pile doesn't fall down. But I want to tell you a little controversy also. Look at this. If someone says, if I pull it this way, then the book lying above the pulled book are at rest, but they are not falling down because they are sharing the force which I am applying on single book. But if force is applied in a jerk, then they do not share the force applied on that book, and this is because of inertia of rest. Let's talk about the inertia of motion also with example. Look at this. Inertia of motion, what is it exactly? Inertia of motion is the tendency of a moving body to continue its state of uniform motion in a straight line. Have you noticed this? I am not saying only continuous state of motion. I am saying continuous is state of uniform motion in a straight line. What it means? It means if a body is moving towards this direction at the rate of 10 meter per second, then it tends to continue its motion in the same direction, in the same straight line with the same value of velocity or continuous motion. This is told in the definition. We can take example of the previous video. Look at this. I want to match this definition with the previous video clips. At this time, a person who jump out of the train, when his feet touches the ground, feet comes to rest. But previously when he was in the train, his whole body was in the state of motion, and it had inertia of motion and tends to continue the state of motion. But when he jump out, his feet touches the ground, and ground is at rest, and that's why the feet comes to rest along with the ground. Along with the ground, feet comes to rest quickly, but the upper part of the body tends to continue its state of motion, and that's why he fell down. Now let's talk about another example also. At this time also, the books which were kept on the chair, they had inertia of motion, and because of that inertia of motion, it continued that inertia of motion in the same direction with the same motion, and so all the book fell down in another chair. Now look at this also. Both of them had inertia of motion, the rider also, horse also, but horse came to rest by stopping its body on the ground, but the rider was in motion, so it continued its state of motion in the straight line, so she fell down. Now this case also, the bike was in motion and it gained lot of inertia of motion, and because of this huge inertia of motion, the bike is able to cross that lake also. These are the example of inertia of motion, and why it happened also I answered. Okay, now let's talk about inertia is advantageous or disadvantageous. The question is whether it is advantageous or disadvantageous. We cannot say exactly, but there are many places where inertia is advantageous, but in many other places it is not so advantageous. Let's talk about this advantage only. I am talking about advantage only. Inertia is advantageous. Yes, we can take example of athletes. Look at this video. An athlete who is taking part in long jump, he runs for a while, few seconds he runs, and then only he jumps. And what is happening here? Exactly when he apply force just before the jump, that force makes him to jump a little distance, but previously if he runs for a while, then what happens? The body comes in inertia of motion, and this inertia of motion will be added up at the time of jump. I mean to say, it will be added up at the time of jump when he apply force on the ground to take a jump. The previously gained inertia helps him to jump a little longer distance. For this reason, usually a long jumper runs few seconds before taking the jump. Not only this, look at this is an athlete who is doing high jump. In high jump also, an athlete runs for a while, and when he applies force on the feet to take a jump, and then he will be able to cross that bar. But before that, he takes a little run. Why? He wants to gain inertia of motion that will be added up at the time of jump, and he can jump a little high than what he can. That's why we can say that inertia is somewhere advantageous, but maybe somewhere not advantageous. Okay. Now I want to present some of the very common experience of our daily life related to the bus. And what are they? relate following daily life experience with inertia. We can say this also, or just answer the following question also enough. Look at this. When a moving bus is suddenly stopped, passenger jogs forward. How can we relate this with inertia? We can answer like this. If a bus is moving, then the body of the passenger is in motion, and the body has inertia of motion, and it tends to continue the state of motion. But when it is suddenly stopped by using brake, then what happens? The lower part of the body, which is in contact with the seat, we are sitting on the seat, the lower part of the body quickly attains the state of rest. It comes to rest simultaneously with the bus. But the upper part of the body was in motion, it tends to continue a state of motion. That's why upper part goes forward this way. This is the reason. When a moving bus is suddenly stopped, passenger jogs forward because of the inertia of motion. Lower part attains the inertia of rest. I mean to say, lower part attains the state of rest quickly with the bus, but upper part tends to continue the state of motion, and because of that reason the upper part of the body jog forward. Now look at another question. When a bus suddenly starts to move, the body jogs backward. What I mean to say, we are in a bus, it is started but not moved. Sometimes what happens, driver suddenly applies force on the accelerator to move the bus, and we'll jog backward like this. We'll jog backward this way. What is the reason? What is the science behind this? The science is inertia. We can explain this way. When a person is in, or a passenger is in bus, his body is at rest. It tends to continue its state of rest. But when the bus suddenly moves, then lower part of the body, which is in close contact with the bus, quickly attains the state of motion along with the bus, but upper part, which is not in close contact with the bus, tends to continue the previous rest position, rest state, so it jogs backward to continue the previous rest state. This is the answer of this question number 2, or relation of this question with inertia. Okay, now let's talk about another matter. When a bus turns towards right, then the passenger incline towards left. While moving in a bus, if driver suddenly move towards right hand side, then if driver moves the bus towards right hand side, then our body tilt towards left hand side. What is the reason? To answer this question, I want to say something a little different than this. In some of the book, what I found, inertia is of 3 types. Inertia of rest, inertia of motion, inertia of direction. But exactly inertia of direction is contained in inertia of motion, because in the inertia of motion, what I told you, it tends to continue its motion in the straight line, uniform motion in the straight line. It means the inertia of motion grabs the inertia of direction also. This is related with the direction, and inertia of motion and direction also. When a bus turns towards right hand side, when driver turns the bus towards right hand side, then what happens? The body of the passenger was moving straight in the motion, and when it is turned towards right hand side, then the body tends to continue its state of motion in a straight line with the same uniform motion in the previous direction. So previous direction is left, it is left towards left, and that's why body tilt towards left, but bus turn towards right. This is the reason. This is because of inertia of motion and direction, also the body tilt towards left hand side. Okay, next question, look at this. When a bus turns towards left, then the passenger incline towards right, just opposite of this previous. If a bus turns towards left, but this must be a little stiff turning. A little turning doesn't make any difference to our body, but if the turning is a little stiff, then our body tilt towards right hand side. The reason is the body of the passenger of the bus was in motion, and it tends to continue its state of motion, uniform motion in the same straight line, but the bus is turned towards left. So to continue, the upper part of the body actually tends to continue, the lower part attains the direction of motion also, change direction of motion also along with the bus, but the upper part tends to continue its state of motion towards the previous direction. That's why the body tilts towards right hand side. Okay, this is all about the inertia for class 9. What we did today, we did a lot of things. Now I think you are able to define inertia. Now you are able to express on which factor it depends and how. Now I think you are able to differentiate inertia of rest and inertia of motion, and you are able to define them also. You can take different example, you can give different example of daily life also. I think so. Okay, next class we will meet with some other subject matter. This much for today. Thank you.